everyone. All right, so guys, guess what we're starting today? Drum roll, please. We are starting trigonometry. Yes. Okay, come on, get excited. Yes. Now, hey guys, trigonometry, believe it or not, just means the study of triangles, specifically right triangles. Hey, haven't we already been studying right triangles? Yes. Now, we're going to introduce you guys to something that you've already done. And did you guys know you've already been doing some trigonometry? And you didn't even know it, did you? See, we're slick like that, aren't we? Yep. Okay, so guys, what we're going to do today is we're going to use the Pythagorean theorem and the converse of the Pythagorean theorem to solve some problems. Now, you guys know what the Pythagorean theorem is. Let's take a look. Okay, you guys remember the Pythagorean theorem says a squared plus b squared equals c squared. Okay, now I want to review with you guys just so that we're all on the same page. Okay, just as a reminder, ladies and gents, the hypotenuse over here is always, always, always opposite of the right angle. And it's always, and you guys can write this down, it's always, always, always the longest side. Okay, that's something you're going to need to remember. Now, the sides that are adjacent to the right angle, notice that, and let me highlight here, these sides right here create the right angle. Guys, those are called the legs. Well, guys, that's going to be your A and your B when you use the Pythagorean theorem. And it doesn't matter which order you put it in, okay? Because, guys, look right here. When you add, right, and you use the Pythagorean theorem and you add, when you add a squared plus b squared, it's the same thing as saying b squared plus a squared. So it doesn't matter what order you put the legs in. All right, now, let's get a little bit more in depth. Okay, let me erase this, get this out of our way. All right, no, the Pythagorean theorem is used to find the length of a side in a right triangle. So I'm going to say that again. In a right triangle. You can only use the Pythagorean theorem when you have a right triangle, okay? So if you need to write that down somewhere, please write that down, okay? All right, now, Pythagorean theorem. There is something called the Pythagorean triple that deals with the Pythagorean theorem. Now, there are two things that must be true in order for us to have a Pythagorean theorem or Pythagorean triple. So let's take a look. First of all, it is a set of three positive integers. That means that they are whole numbers. No decimals, no fractions, no radicals. They are three whole numbers. So if you need to write that down off to the side, integers means three whole numbers. Okay? Now, that's the first thing. That must be true. They are three whole numbers, and a squared plus b squared has to equal c squared, okay? So those two things must be true in order for us to have a Pythagorean triple. Okay, so these are some common Pythagorean triples, you guys. 3, 4, 5 triangle, okay? So notice that they're all whole numbers, and if I were to take 3 squared plus 4 squared, it equals 5 squared. Okay, now this one's another one, the 9, 12, 15. Well, maybe, maybe not. Well, we got to check it. First of all, yes, they are three whole numbers. And then we check to see 9 squared plus 12 squared, does it equal 15 squared? Notice that again, I set up my C is the longest side. Okay, and if you guys were to work this out in your calculator, sure enough, you would get that 225 equals 225. So yes, this is a Pythagorean triple. Okay? All right. Now, remember I told you guys we were going to talk about the converse of the Pythagorean theorem. So let's talk about what that is. The converse of the Pythagorean theorem, guys, we're going to actually put the c squared on the left-hand side. And what we're going to do is we're going to use this, the converse of the Pythagorean theorem, to classify triangles by its sides. We don't even have to graph it. All we need to know is the three side lengths, okay? And what we're going to do is fill in the values. Notice right here, okay? And I'm going to highlight this. If c squared is less than a squared plus b squared, then the triangle is acute. Okay, and notice, guys, we just kind of talked about this. If c squared, oh, wait a minute, we didn't talk about this yet. If c squared is greater than a squared plus b squared, then it is obtuse. Okay, and this is what we just talked about. Let me get my head on straight here. If c squared equals a squared plus b squared, then it is a right triangle. Okay, now again, notice, guys, notice where your c squared is. Your c squared is on the left-hand side. And I'm going to show you guys how we're going to set this up and how we're going to classify these triangles just by using a squared plus b squared is either less than, greater than, or equal to c squared. So let's go take a look. And hey guys, you know what? I'm looking at my notes over here. Hey, let's go start with number 3. Let's go start with number 3. I'll meet you down there. Alrighty, y'all. Down here at number 3 and 4, it says to find the value of x and then determine whether or not the side lengths form a Pythagorean triple. So remember, in order to have a Pythagorean triple, what 2 things must be true? Okay, hopefully you guys look back in your notes and you were listening to what I said in the video and you said, hey, Miss Smith, in order for us to have a Pythagorean triple, they have to be all 3 whole numbers and a squared plus b squared has to equal c squared. Okay, so let's go find x and let's see. Is it a Pythagorean triple? Okay, because I have a right triangle and because I have 2 side lengths, I can use the Pythagorean theorem. Remember, a squared plus b squared equals c squared. Hey guys, do you guys remember, I said it just a second ago, which side of a right triangle always, always, always has to be C? Okay, hopefully you guys remembered and you said, hey, Miss Smith, I remembered what you said. The C is always opposite of the right angle and it's always the longest side, right? And 10 is the longest. So guys, we're going to plug in 10 for our C. So that would be 10 squared. Okay, and then your legs are the A and the B. So it doesn't matter what order we plug those in. So we'll do x squared plus 7 squared. Okay, now, guys, use your math algebra skills, and I want you guys to see, can you solve for x? And if so, hey, guys, what do you get for x when you solve for it? Tell me what you get. Okay, how'd you guys do? Okay, so look at my work. If you did not get it correct, look at my work, see where you might have made a mistake. And then, guys, I'm going to ask you, based upon our value of x, are these 3 numbers, do they form a Pythagorean triple? Yes or no? Okay, hopefully you said, Miss Smith, no, they do not form a Pythagorean triple because they are not 3 whole numbers. Okay, they have to be 3 whole numbers. And notice, guys, this one right here is a decimal, isn't it? It is not a whole number, so it's not a Pythagorean triple. Okay? All right, so remember, Pythagorean triple, 3 whole numbers, and a squared plus b squared has to equal c squared. Okay? All right, hey guys, let's shift gears and let's keep on going. Let's go look at number 8. Go down to number 8 with me. Whoa, Miss Smith, this is different. This is asking us for area. Yes, guys, we're going to be doing area of a triangle, which you have already learned before in previous classes. Okay, but let's talk about this. So I'm going to zoom in on this, and it tells us that we have an isosceles triangle. Now, ladies and gents, we've learned this earlier in the year. If you have an isosceles triangle, which means that these 2 sides are congruent, and you have an altitude that comes down and is perpendicular to the side. We've learned this. Do you guys remember, what does this altitude do to this side length? Do you guys remember? All right, so hopefully you said, Miss Smith, I remember. Okay, this is from Unit 5. The side over here is bisected. Okay, so in an isosceles and an equilateral triangle, whenever you have the altitude that comes down from the vertex angle and it's perpendicular to the side, it bisects the side. Oh, so that means that each of these sides is 18 and 18. Okay, now that we know that, ladies and gents, now we can focus on just one of these right triangles here to find the height. So when I say focus on one of those triangles, here's what I mean. Do you guys notice that there's two right triangles here? Well, really, what we need to do is just focus on one. Okay, and notice right here, I'm covering up one of the triangles that we don't need. So what we can do is we can say, okay, now let's focus on this triangle on the left. Okay, can we find the height? Yes, because remember, if one side is 90 degrees, the other side also has to be 90 degrees, so we have a right triangle. And now that we have a right triangle, we can use the Pythagorean theorem to solve this. Okay, so guys, I already set up one of the problems earlier using the Pythagorean theorem, so I want you guys to try to set this one up. All you're going to do right now is choose which of the following equations is the accurate way to set this up to solve for h. Okay, hopefully you set it up correctly. If not, guys, look at this. Remember, always across from the 90 degrees is going to be your C. So I plug that in for C. Okay. All right. Remember, these legs right here, doesn't matter which order you put those in. Okay, guys, your turn. Solve for H and tell me, what did you get for H? How did you do? Did you remember the units, right? Because our side lanes have a units of feet on them. So our correct answer is 14.3 feet. Okay, you got to remember those units. All right, next up, it's asking us for the area of this triangle. Okay, so the formula for the area of a triangle, and most of you will remember this because you have been taught this in previous math classes, is 1/2 base times height. Okay, that's great, and formulas are fantastic as long as we know what to plug in for them. So the base and the height in any shape will always, always, always be perpendicular. Okay, so let's go look at our shape right here. The base and the height will always be perpendicular. Having said that, do you guys see that the height right here, which we know, is perpendicular to this whole entire side? That whole entire side is your base. Okay, so let's plug this in. We have the height, we know the base. So if we plug this in, area equals, if I can remember to get back to where I was going. All right, let's try this again. Okay, area equals 1/2. Hey, ladies and gents, isn't 1/2 the same thing as 0.5? Yeah. Okay, so area equals 0.5 times the base, which the whole entire base, the whole thing was 36 feet. That was our base. Okay, and the height, well, we found the height. The height is 14.3 feet. Okay, now, guys, all we got to do is plug this into our calculators, and you can plug it in just like you see on the screen, and you should come up with the area is 257.4. Now, here's my question. What units should we put on this area? What do you guys think? Okay, let's see if you remembered that area is in squared units. So this should be 257.4 feet squared. Okay, that would be our final answer, feet squared. Okay. All right, so that one's a little different. Do you guys see how we're applying the Pythagorean theorem and now we're solving for other things? Yes, we're going to be doing that quite a bit. Okay. All right, let's go down next. And hey, guys, let's go take a look at number 11. I'll see you down at number 11. All righty, down here at number 11, guys, what we're going to do, and it actually tells us in the instructions there, 10 through 13, we're going to determine whether or not we have a right triangle. Notice there's not a box on any of these shapes, is there? Okay, so how do we determine it? Well, we're going to use the converse of the Pythagorean theorem. So I'm going to show you guys, we're going to set this up a little bit differently. Okay, in order to test it, what we're going to do is we're going to start this out. First of all, remember I told you guys, c squared is always going to be on the left when we're using the converse. Okay, and then we're going to put a box. Is it greater than, less than, or equal to a squared plus b squared. Okay, so remember I told you guys that c is always, always, always your longest side. Hey, don't just go by the way it looks on the screen. Guys, in order to determine which is the longest side, well, we have a square root. Unless you magically have a calculator in your head and you know what the square root of 26 is, hey guys, use your handy dandy calculators. Plug in the square root of 26 and it tells me that it's 5.099. Hey, isn't that longer than 5? Yes. So the square root of 26 is our longest side. So I put in the square root of 26 squared. And remember, I don't know if it's greater than, less than, or equal to. And then I'm going to plug in the a squared and the b squared. Does it matter what order we put it in? No. So I'm going to do 5 squared plus 1 squared. And then we're going to work this out. Guys, this is where the rules of radicals and exponents comes into play. Do you guys remember that if I take the square root of 26 times the square root of 26, it just gives me 26. Okay, remember that from rationalizing the denominator, right? Okay, and then 5 squared is 25, 1 squared is 1. So we're going to see here 26, and then is it greater than, less than, or equal to? 25 plus 1 is 26. So, hey guys, these are equal. Because they are equal, that means that yes, we have a right triangle. Remember, if c squared is less than, then it's acute. It's not right. If c squared is greater than, then it's obtuse. It's not right. Okay? All right, now, guys, all we're doing in this first part is testing to see if you have a right triangle. But now as we go down and look at, I think we're going to go down and look at number 17, we're going to classify these triangles and see what kind of triangle do we have. All right, so I'll meet you down at number 17. All right, hopefully you guys read the instructions for number 17. Okay, it says that we want to determine whether or not those 3 side lengths are going to even make a triangle, and then we're going to classify it as acute, right, or obtuse. Hey, ladies and gents, in order for it to make a triangle, there is something that needs to be true, and you might want to write this down. In order for it to make a triangle, 3 side lengths to make a triangle, okay, 2 side lengths, the 2 shorter side lengths, must be greater than the third. And again, you guys have already learned this before. Okay, well, let's see, the 2 shortest side lengths. Do we know which 2 are the 2 shortest side lengths? Not yet. Well, what we need to do is put the 5 square root 13 in our calculator and see that that's actually like 18 point something, something, something. So that's our largest side, isn't it? Okay, so let's test it. Okay, so right here, 10 plus 15, okay, remember your 2 shorter sides, are they greater than the third side, which is, and I'm just going to round it, it's like 18.0. Okay, so 10 plus 15, that's 25. Yes, that is greater than 18, so yes, we have a triangle. Again, your 2 smallest sides, okay, you're going to add them together, okay, and you're going to see must be greater than the third, must be, okay, greater than the third. Okay, and I'll actually put the longest side. Okay, so if you want to write that down somewhere so that you know, this is how to determine, do they make a triangle? Okay, your 2 smallest sides must be greater than the longest side, okay, when you add them together. Okay, now, guys, we need to classify if this is acute, right, or obtuse. So we're going to use the converse of the Pythagorean theorem. C squared box, okay, a squared plus b squared. Okay, so we're going to test to see. Well, what do you think? Let's see. We got to plug in the longest side, which is 5 square root 13 for C. We're going to square that. Okay, greater than, less than, or equal to a squared plus b squared. All right, so 10 squared plus, 15 squared. All right. Well, guys, do you remember how to solve this? So let's look at this. Okay, when we zoom in here, guys, remember, when you have the parentheses and that thing is squared, that's telling you that inside the parentheses, this whole thing is squared. Because these are multiplied together, we can then distribute that squared. So this would look like 5 squared times the square root of 13 squared. Okay, greater than, less than, or equal to. Well, hey guys, 10 squared is 100, 15 squared is 225. All right, guys, let's see. Using what you learned during when we were doing exponents and radicals. Hey guys, can you tell me what is going to go over here on the left-hand side? What do you get when you take 5 squared times the square root of 13 squared? All right, so hopefully you guys said, hey, Miss Smith, this is 25 times 13, which is 325. Okay, 325. So 325 greater than, less than, or equal to 325. Holy cow, it's equal to. So if it's equal to, hey guys, what kind of triangle do we have? All right, hopefully you said, hey, Miss Smith, if it is equal to, that means that we have a right triangle. Okay, now notice we used the converse of the Pythagorean theorem, and I worked out one for you that had these radicals in there, so to kind of help you out. Okay, ladies and gents, you're going to work out the rest of this assignment in class. Okay, and remember, ask questions. This is the beginning of trigonometry. There's going to be questions. It's okay. All right, and until then, you guys know what it is. Adios.